All right, so two-dimensional motion, horizontal free fall. This is where you have an object that has an initial x velocity, but not an initial y velocity. Through this, we're going to have to look at how vertical and horizontal motion are independent of each other, look at the path of a projectile, changes in its velocity, and do some math with calculating time and distances that we find there. And of course, you're going to need your reference tables for the formulas. So we can start off with by watching this clip. All right, so see at every point here, the ball on the left, which is just being dropped, and the ball on the right, which is being pushed off, are always at the same height throughout. This means that horizontal and vertical motion are independent of each other. So now let's take a look at a sample problem here. This is one you could see on the Regents exam or on a test. An object is thrown from the top of a 100-meter building with a horizontal speed of 5 meters per second. How far away from the base of the building does it land, and how fast is it moving when it hits the ground? So first off, let's start by drawing out our scenario. We start with our building, which we know to be 100 meters high, and we have a ball that's going to be on the top, or an object on the top, that will be thrown off the edge and take the path of a parabola as it hits the ground. We know that we're looking for the distance, and eventually we want to figure out how fast it's moving as well. So the first thing I'm going to do is now I'm going to look at my y and x components, break out what part of this motion is vertical and what part is horizontal. And we can look at things like the velocities, the acceleration, the distance, and the time. In this case, my y velocity is 0 because I'm dropping it. I'm not throwing it up, I'm not throwing it down, and I also know my x velocity is 5 meters per second. My final velocity vertically I'm looking for, while my x1 is still going to be 5 meters per second because there is no acceleration horizontally. Vertically, I do know that gravity is going to pull it down, which means my acceleration is 9.81 meters per second squared, and I have to fall 100 meters. The horizontal distance, I don't know, but that's one of the things that I'm going to look at finding. And then, of course, I don't know the time I'm in the air either. So knowing this, the first thing I need to do is figure out how to find the time I'm in the air for. So let's take a look at which column here, the vertical or horizontal, is going to give me the information to do that. Now to find time, I know a whole lot more information in the vertical column, so that's the one I'm going to use right now. And looking at my reference tables, I chose to use the formula d equals VIT plus 1/2 AT squared. I know my vertical distance is 100 meters, my initial velocity is 0, so that whole term drops off, and I know my acceleration, and this will let me find the time here. So a little division, little square rooting, and I can figure out the time that this ball or this object's in the air for is approximately 4.515 seconds. Okay, I'm leaving more decimal points here than I normally would because this time is going to be used for my other calculations as well. Okay, now time is special because that's the one quantity that applies to both the horizontal and the vertical parts of this motion. So it's going to go in both columns. Now that I know the time, we can figure out how to find the horizontal distance, or how far away from the building this object is going to land. Okay, looking at my list of stuff, I'm going to choose to use one of the formulas with d in it. In this case, d equals VIT plus 1/2 AT squared. I could also have used the velocity equals distance over time formula, and I could have done that because my acceleration is 0. So I go ahead and plug in the numbers I know about here. Again, my acceleration is 0, so that just drops off and goes away. And I find out that my distance here is approximately 22.58 meters. Okay, so now I know the distance, I can add that to my chart, and then we'll get around to finding the last piece, which is our vertical velocity in the y direction, and that's the final velocity. Again, using y information here because I'm talking about the vertical axes. And this one's pretty straightforward. VF equals VI plus AT. There's a lot of other formulas I could have used as well, but this is just my personal preference. So I know the acceleration vertically, 9.81 meters per second squared, and the time I know as well, 4.515 seconds. So a little multiplying around here, and we end up with a final velocity of approximately 44 meters per second, or 44.3 meters per second. Okay, and there's the speed of the object there. So again, going over the steps, first we found the time, then we can find the distance and velocity, whatever else the question asked us to do.